So welcome again for the part 2, where we are going to explain you more about the results visualization and the analysis. So in this part 2, we are going to show you the different ways of showing the results, whether it is a slice, which means it is a plan in which you are looking at velocity, pressure, or direction with arrows. You can also add labels to any of this component. Then you can look at threshold. Threshold are domains that you choose where you show between two values the volume which is contained in these two values, like for instance either a velocity from 0 to 1 meter per second, or if you want to see the pressure which is negative between 2 and 3 Pascal or positive between 1 and 2. Then you can also see streamlines, which are the actual path of the particles. So it's more something to help in going beyond intuition and to see how the air is moving for each particle. And then the building surface is an interesting feature which gives you actually the pressure or the velocity on the surface of the building itself. Then you can also have cross-section across buildings, especially when you have multi-layers with internal flows. The clip-in pane allows to visualize this. Then you can generate PDF reports for each of the variation you do for different parameters as well and different plans. But then it is very useful because you can then compare different variation you did in simulation after going on the screen. Then you can really systematically look at the difference. And then we will end up this part by showing few examples of analyzing the results for some few cases. Then after that, we will have another part showing an example of process of design with Vayu Pravah, going from block level to internal flows for this. So first, we are going to look at the type of visualization. So the simulation, once it is completed, and you have seen that once you have completed, you just click on the Done button, and then you enter into the visualization. And then you have to choose the variable that you want to display. So you can display the pressure, you can display the velocity magnitude, that means the vector of the velocity in all direction, then the velocity along the x, y, and z. X is the horizontal axis following the wind, y is the lateral axis, and then z is the vertical axis. Then you can also view different types of visualization. As I mentioned, the slice, the threshold, the streamline, and the building surfaces are the four possible view that you can have. Then you can see here a slice view with pressure. That means horizontal plans, which is perpendicular to the z-axis, the vertical axis, where we show here pressure. You have here the label scale, the value scale, sorry. And here you can see with arrows the air movement. So you can have a combination of pressure and velocity shown on the same. Then you can change to velocity magnitude as well after. And you just change the variable, and then it will change to a show of the velocity. Then, so this is just to show you a typical example. Once you have got the end of simulation, then you can load the results. Then you decide you want to be on pressure, you want a slice on a horizontal plane, and then you decide that you want to put it at 5 meter height. And then you generate. Then after, you can remove the slow slice indicator, because then you can move without interacting with this slice indicator, which is helping moving the plane. And now you can change to velocity magnitude, and then you get the velocity distribution in this height of 5 meters. And then the other thing that you can see that you have a scale by default, which is not exactly very nice, so you can change it later, but that will show you after. So then you can generate with the velocity arrows. You can add labels then also. So you can add labels of velocity, magnitude, or pressure, or whatever you want, near or far away or wherever. So you get an idea of at some points, specific points, whether you have a good velocity or not. You can remove them by clicking on the bins. And then you can change again and go on building surfaces. So when you go on building surfaces, then you can see the pressure shown on the following the same scale on the different element or facade of the building, so that you can also get an impression on how the wind is actually performing and whether it is in negative or positive pressure. And you can think of planning then more in detail if you want to go for a kind of building which is, as per, we can say, a conventional approach, windward, leeward. That means the wind is pushing through. Or if you want to try to have the wind passing along the facade and try to catch it. Or again, if you want to see on the roof whether you have a chance to have a negative pressure to have some suction effect. Then the threshold representation here you see on the left, you see on the left bottom a view of typical quadrangular buildings which are on the same height. And you see that when there is another construction in front, then the wind which is between the buildings, and even if there was not, is very poor. So you can visualize that better with the threshold showing that all these volumes are at very low velocity. So this helps visualizing the zones on a 3D level, three-dimensional level, as compared to the two-dimensional which you get with the slice. Now we show you how you can zoom and scale and change the variable, and also so you can move with the slice indicator. You can generate, and then you can see that if you are looking at the velocity far away, when the wind is coming and passing far away, you can see here with the scale of 9 meters per second, it gives you an idea of the wind. Now, if you bring the slice at above the, or let's say perpendicular to the building, then you can see, and zooming, you can change the scale, and then you can show, by changing the scale, you can then have a better understanding of the local condition now. So you can see here that you have a very low velocity available, but that you are getting a much better potential if you would go higher. By the development of the boundary limit layer, you can see that you have almost 7 meters per second above the roof, but a very poor. So which shows you could think of trying to get something where you are going to work with a suction effect through courtyards. Then the Streamline vision is something which shows you how a particle of air, and coming from the left here, is going to pass along different, this is what we call the streamline. That means the air, a particle of air is going to follow these streamlines. So now if you can do different things. You can increase the density. That means by high, going from low to high density and generating, you can get more streamlines. It's rather something which is more to illustrate how the air is moving and how it is going, how each particle is going. Then you can also change the size of the seed box, so to say, so that you can have different way to look at the streamlines. You can also remove the seed box so that you only see the streamline visualization. So this is again something that you cannot use directly with numbers really, but you can really visualize how, if you would follow a particle, it would be along one of these streamlines. Then the threshold level is something which is interesting to look at. And you see here again the demonstration how you can vary the density and move it, and you can visualize quite nicely the whole thing. Then the building surface representation is that you have then the building surface with their pressure or velocity. And if we go on this, then if you pass from streamlines to building surface, then you get the buildings with the color corresponding to the scale that you have. And then you can then mark wherever you are and show the pressure which are on the facade. So you can really see one side and the other of the facade by moving with the representation. You can really see the different pressure you are getting. So it gives you an idea of the potential of cross ventilation that you may have. So, oh, sorry. So then you can adjust the scale as I have shown you already, but now you can see really if you go in under results and color map, you can use custom color map range, and you can edit this custom parameter. So which means you can then adjust the scale, so you can see it dynamically here. You use the custom scale and then you adjust the custom scale, so you can change. So if you want to look at the pressure, you say, no, I'm interested in having another scale, for instance. And then at this moment you have the picture, which is, you are able to get your own view and colors as you want. So now you can also generate a PDF report. So whatever you want, you can do it by plans essentially. So you can choose whether you want a pressure, on which plan and on which interval you want. So typically, if you have a building, you can take the Z normal, that means the horizontal plane, and then you will try to adjust the axis bound so that you get a plane every 3 meter or 3.2 meter corresponding to the different floors. So it gives you an idea of the change of the airflow or pressure value in a plane. So the report is then, once you have defined the PDF file, then you are saving it, and it's saved by default in the report subdirectory of the project. And then after that, you can go you can visualize this process of the PDF report. So you can generate the PDF report, you can choose the pressure or the velocity, let's say in this case, and you want to have 18 plans generated once every meter. And then you can just say to generate. It will take a little bit time, few seconds normally to generate. And then you can open the PDF file, and then you get at each meter in this case, because you have defined the number you wanted. And so then you can then compare them with different variation you have been doing. So then once you have results and you have more than one, then you can reload results that you already have from other case. And that is done by simply go in the edit, reload results, and then you can choose in a table all the simulation you have been already doing are with their name and version. And then depending also, it's interesting because you get the direction, the velocity which was chosen, the height, and the environment you choose, as well as the date. So it's a quite practical. Oh, sorry, what happened? Oh, there is a mistake on this. So this was just a demonstration in dynamic, so I think it's not so important. Then the other thing is, what you can do also is to make cross-section in the building, especially the one which have one floor, for instance, where you have the openings to simulate the airflow which is going through the building. So we just saw again an example just to explain this approach, so that you have the typical block that represent the bottom of the building. Then you have the closed facade with patterns, which is on this B level, so to say. And then in C, the C typology is then above this. And then that's where you have this opening. And so then you can see, this is the bottom layer, this is the second layer, this is the third layer, this is the fourth layer, this is the fifth layer. So then you can see that when you want to add the layers, you have to go in the drawing editors and you add layers here, and then you can visualize that. So you have to set the height of the layer. If you add a layer, you have to add the bottom of the layer in this field. And once you have introduced this, you will have to set up the height of the layer. That means from the bottom of the layer to the top of the component. So this small video is showing how you first create a new case. That's a kind of rehearsal. You have already seen it. So we start by the first layer, and you see that now we have only blocks, and we start from the ground. And then so that's it. Then after you add, you select the building and you define the height, which is the height between the bottom of the layer and the top of the layer. And that's how you give it. So when you have selected the building, is the color changed to brown, and so then you can adjust the height for all of them at once. And then we have another video showing how you do it. Just it's a little bit repeating, but I think it's important that you understand this kind of basic things, so that you can see how the height is fixed. And then, so after, you need to add the next layer, which is the facade, which is closed. And so then what you have to do is to go to the next one, next slide, and then what you select what you want to have in the layer. So here, if you see, we have just, this is a full buildings, in a sense. We have a profile outside, but inside it's filled. But we don't want that. We want to open inside the building. So we open inside the building, keeping the facade closed. And then after, we specify the layer height when we have selected the 3 buildings again. Then this is just seeing in dynamic the same thing. So you just click here and you can just select what you want from the building or not. So the blue is what is selected. Then you set the height of the bottom of this layer, 5 meters, for instance, in this example. And then after, you are selecting the layer and then giving the height of this layer from the bottom. So it starts at 5 meters and it goes up to 7 meters. That means 2 meter height of the layer. Okay, so here we have the second layer that we must add. So we have to select, we have placed the second layer at 5 meters, and now we add 2 meter height of this layer. So here it shows how you are adding the layer above with above the sill, and now you have the open facade that you are adding, and then you give again the height of the opening. Let's say that it is 2 meters, and then you add again the fourth layer, which is then again an open inside, but then it is with a closed facade element. And then, so you are entering the same layer, starting at 9 meters at the bottom, and you add a 2 meter height. And then the fifth layer is the same. You add then a block to make the final height of the building with a block. And you are also doing this systematically. So now we are adding the height for the fifth layer here again. In this case, it was decided to add only 3 meters. And then from there, you can select, you can launch now the switch from the drawing editor to the simulation setup, which will allow you then to launch the simulation. So here you can see again, adding the layers. You can see the dynamic is just as a kind of reminder of what we just explained before. So you first select with this, by clicking on this tool, you can select all the building of the layer. Then you have the 11 meter at the base, and then you are adding another 2 meter for the example. Okay, so now you are jumping to the simulation setup. So the simulation setup shows you again, as already explained before, but in this case, we just go through one example through. So you can select then the height of the building if needed. You can visualize in 3D. You can see here, then you can visualize it moving. You can move the 3D as you want. You can zoom. You can even add clipping planes also, if you want. So it allows you to check that you have properly introduced the different height. And if you have more building of different height, you will also see them then. Then you have to go to the simulation setup. And that is where you are giving the environment conditions. So you choose the wind profile, which is given from city, suburb, village, forest, etc. So these are different possible profile which give you how the wind is changing with the height when it's coming from far away. And then you can also give the reference, and then the reference velocity, the direction of the wind you can specify here. So you can also, as mentioned before, you can also clip to see if your building drawing in 3D corresponds to the addition of the layers, and if you are if it's correct, then here you see, for instance, the selection. You can change the height of the building at this point also if needed. You select then the environment, the velocity, then you select. You can also make a clipping plane as shown before in different on different kind of planes. And then after that, you can then decide how the wind is coming also. You can change the wind, and then later you can launch the simulation. The moment you launch the simulation, you must have saved the project. You could save the project earlier, but often when you define a new project, you develop your cases, and the moment you want to run the cases, it asks you to give the project name and the location of the project that you are going to store. And so then after it shows you, it's just a clip showing you how you do this, just project name, and then select the folder. Then you can start running the simulation. So during the meshing, you have this blue arrow, this blue bar, which is there. And the moment the meshing is finished, then you have the simulation, which will indicate how long approximately the simulation lasts still. And then once you have completed, if you click on if you click on the window, then you will have the two blue with the two arrows saying it's good. So you can then just go to the results by clicking on done. And then you can then have different views like we already mentioned before. So you can just now go through and here you have an example on how you can select slice, move the slice, and also clip planes that you can adjust as you want. Important is to select before, when you are going on the change the color map, to select the one that you can adjust yourself. And you can also again clip. You can visualize the airflow here. In this case, the slice is below the clipping planes. Then after, you can also visualize. You can visualize the different streamlines, which gives you an idea. And you see here that the streamlines are going. Some of them are going because it's a relatively low density, but you can see that the airflow going through the building and going out after. And then you can clip the results along the dead axis, and which is quite useful. So if you go in the dead axis and give the position you want, then you can remove the slice indicator so that you can move without moving the plan again. It will, and then you can select the clipping plane and have it exactly adjusted to the height you want. So you can visualize quite nicely the airflow through the building as well. Here you can see how you can change from the Streamline going to the building surface visualization. And so there you can see that you can easily show with using the labeling, you can really see how the pressure is actually happening on the facade of the building. So it gives you a good understanding of or potentially a good understanding of the pressure difference on different surface, and help in thinking about the way you are going to design your cross ventilation system or your facade design, or relocate the buildings differently or reorient them. So this was the, let's say, second part, technical presentation. It will be followed after the break by the third part, which will show two examples when we work from the macro level down to the building level, as an illustration of the process that can be followed with the software. So thank you for your attention, and hope to interact with you.